Hello, cool science kids. Welcome to Miss Price's Kitchen. This morning on Miss Price's Kitchen, we're going to have a wonderful lesson about conduction, convection, radiation. I know you have studied all three of those things. You've seen examples, and I just want to make sure that you got it. So, for starters, let's start with conduction. So if I have my lovely refrigerator, and I reach inside, and I pick up a jar of jelly. Right now, the heat from my hand is going into this jar of jelly because it's making direct contact. And what that means is that the atoms in my hand are moving faster than the atoms in this glass, and they're colliding. And whenever they collide, the atoms from my hands are slowing down on the edges, and they're speeding up on this glass, making it warmer, making those atoms on this glass, or in this glass, that the glass is made up of, is going faster. So conduction, direct contact, all has to do with those atoms touching and colliding and making each other going faster or slower. So it works the other way around too. Let's just say Miss Price has her cup of hot tea. Woo, hot. Not really, it's warm, it's not hot. Okay, so anyways, but it is hotter than my hand. So right now, the atoms in my hand are touching the atoms in this glass, and they are colliding. And when that conduction is occurring, it is speeding up the atoms in my hand because the atoms in this teacup are hotter than the atoms in my hand. And we all know that heat transfer is really neat. It always goes from hot to cold, right? So then the heat from this teacup is going into my hand because it is hotter than my hand. But when we were in the jelly was colder, which means that the heat from my hand was going into the jar of jelly. All right, so that's conduction. Convection. So if we have a pot of boiling water, the water that is in here is getting heated up from the heat source, which is obviously not on right now because I would get burned, and we don't want that. But the atoms of water in this container, at the bottom, they'd be getting hot. And we all know that when atoms get hotter, they move faster and they spread further apart, which means that it changes its density. So that means that the water at the bottom is going to become less dense, so it's going to rise up. And we all know heat rises. I know everybody's heard that before. So heat rises up. Well, when that water is away from the heat element at the bottom, then it cools back down. And we knew that atoms, whenever they cool back down, they get closer together and they're moving more slowly. So that's when it sinks back down. This happens with gases and liquids. So convection only happens in gases and liquids. Kind of like when you have a 2-story house and it's hotter upstairs than it is downstairs. Why is that? Because the density of those air molecules are changing based on how hot they are. And the hot stuff always goes up because it's less dense. Just like in our density lab, the less dense stuff goes on top. All right, so that's convection. Radiation. So radiation, I'm actually gonna use my microwave because my tea is warm, but it's not hot. And I want hot tea. Ta-ta-ta. All right, let's heat up this tea. Let's give it a 30-second kick. So while the 30 seconds is going, I'm gonna explain. The heat waves right now that this microwave is producing is going into my cup and into my water. So across that space. So it doesn't necessarily need matter to transfer. So if I was, back to my pot of boiling water, okay? If my hand was out here and I could feel the heat coming off of that pot, then that means the radiation is coming off of that pot and I could feel it on my hand. That's radiation. Okay, I'm gonna go back to enjoying my tea, and I hope you enjoyed this wonderful lesson on conduction, convection, and radiation.